Hi guys! Welcome sa enginerdmath channel. Sa video na to ay tuturo ko sa inyo ang introduction to matrices. So kung gusto niyo itong matutunan, just keep on watching. Okay, so ngayon ay ituturo ko sa inyo ang one of the important topics sa math, which is matrices or matrix. So, etong matrices ay marami siyang gamit tulad sa linear algebra, programming, solving systems of linear equations. So, kaya mahalagang malaman natin yung concept ng matrix. So, define natin ano ba yung matrix. A matrix of order m times n or an m by n matrix is a rectangular array of numbers or elements having m rows or n columns and can be written in the form A is equal to A11, A12, A13, A1n, A21, A22, A23, A2n, A31, A32, A33, A3n, and so on until AM1, AM2, AM3, AMN. Okay, so yung matrix daw, tulad nito is a rectangular array of numbers. So, basically, meron siyang order, which is tinatawag na M by N matrix. Meaning, yung M, siya yung number of rows, tapos yung N, siya yung number of columns. So, for this example, meron tayong M rows hanggang M, tapos meron tayong N columns hanggang N. Tapos pinapangalanan natin yung matrix ng kahit anong letter. Let's say itong capital A. So, this is matrix A, and then naka-enclose yung mga members o yung number or element dito sa bracket. Okay? So, itong matrix na to bale ay order M times N or M by N matrix. Next, each number A sub jk in a rectangular matrix is called an element where subscripts j and k indicate respectively the rows and columns where the element appears. So, bawat member daw ng matrix na to, let's say itong A sub 11 or A11, that can be represented by the symbol AJK, where yung J, siya yung number nung row, tapos yung K siya yung number nung column. So, halimbawa, when J equals 1, K equals 1, therefore, yung element mo is A sub 11 or A11. Meaning, malolocate mo yung element na to kapag pumunta ka doon sa first row ng matrix as well as first column, yung intersection ng first row tsaka first column, which is itong A11. Okay? So, lahat ng element may designation na ganito. Okay, so example, let's say meron tayong specific matrix B, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so, this matrix is a 3 by 3 matrix, or particularly a square matrix, kasi pareho yung number nung row sa column. 3 by 3 kasi 3 rows and 3 columns. Okay? Tapos, pwede nating malocate yung isang particular element. So, let's say, gusto nating malocate yung A31. So, ibig sabihin, ilolocate natin yung intersection ng third row and then first column. So, third row, 1, 2, 3. Ito, diba? Column. First, so, ito yun. So, ano yung intersection nila? Itong 7. Likewise, let's say, A22. So, intersection ng second row and second column. Second row, 1, 2, ito. Second column, 1, 2, ito. Which is 5. Okay, so, ganun lang mag-locate ng element ng matrix through its row and column. Okay? Next, we have the transpose of a matrix. So, ano ba yung transpose ng matrix? This is the resulting matrix when the rows and columns of a given matrix are interchanged and is denoted by A raised to T such that if A is equal to A sub jk, then A raised to T or A transpose is equal to A sub kj. So, pagbabalik ta rin daw natin yung elements ng row sa columns. Kapag in-interchange natin yun, mahanap natin yung transpose ng matrix. So, illustrate ko. Let's say, meron tayong matrix A na 1, 3, 4, 4, 3, 1. So, this is a 3 by 2 matrix. Kasi meron tayong 3 rows and then meron tayong 2 columns. So, pag hinanap natin yung transpose nito, denoted by A raised to T or AT, pagbabalik ta rin natin yung elements nung rows at columns. For example, itong 1, 4, 3, gagawin nating row. As well as itong 3, 4, 7, gagawin nating row. So, itong 1, 4, 3 magiging first row. Tapos, itong column 3, 4, 7 magiging second row. So, parang 1, 4, 3, 3, 4, 1. Okay, so naging baliktad din yung order niya, yung dimension. So, naging ano na siya? 2 by 3. Naging 3 rows and 3 columns. So, pwede nyo isipin na gagawin yung column yung mga row. So, parang A raised to T is equal to 1, 3, 4, 4, 3, 1. So, same lang yon. Okay? Next, we have the symmetric and skew symmetric matrices. So, A, for symmetric matrix, a square matrix is said to be symmetric when A transpose is equal to A. That is, if A is a square matrix, then A sub jk is equal to A sub kj for all values of j and k. So, pag sinabi nating symmetric matrix, so dapat square matrix siya kung saan yung original element ng matrix A ay magiging equal doon sa transpose niya. So, A is equal to A transpose. So, halimbawa, itong matrix natin na 2, 3, 4, 3, 1, 5, 4, 5, 6. So, pag hinanap natin yung A transpose niyan, pagbabalita rin natin yung positions ng rows at columns, right? So, let's say itong 2, 3, 4 na first column magiging first row. Itong second column na 3, 1, 5 magiging second row. Itong third column na 4, 5, 6 magiging third row. So, 4, 5, 6. Mapapansin nyo, kahit hinanap natin yung A transpose nitong A, same pa rin sila nung A mismo. So, hindi nagbago. So, yun yung tinatawag natin na symmetric matrix. Dapat square matrix kung saan kapag hinanap mo yung transpose niya ay same pa rin sa sarili niya or original matrix. Okay? Next, we also have the skew symmetric matrix. A square matrix is said to be skew symmetric when negative A transpose is equal to A or A transpose is equal to negative A. That is, if A is a square matrix, then A sub jk is equal to negative A sub kj for all values of j and k. So, dito naman sa skew symmetric, same din. So, dapat yung A transpose ay equal sa negative nung A. Or negative A transpose ay equal sa A. So, halimbawa, itong given natin na matrix na square matrix A na 0, negative 3, 4, 3, 0, 1, negative 4, negative 1, 0. So, hanapin muna natin yung A transpose. So, ulit, pagbabalik rin natin yung positions nung columns and rows. So, itong 0, 3, 4 magiging 0, 3, negative 4 first row. Itong second column, negative 3, 0, negative 1, magiging second row, negative 3, 0, negative 1. And then itong third column, 4, 1, 0, magiging third row, 4, 1, 0. And then, i-multiply pa natin each term sa negative kasi hanapin din natin yung negative nitong A transpose. So, parang nag-multiply ka lang ng negative 1 sa bawat term. Pwede mong i-distribute, i-multiply isa-isa yung bawat element. So, magiging 0 as is pa rin, 3 magiging negative 3, negative 4 magiging positive 4, negative 3 magiging 3, 0 as is, negative 1 magiging 1, 4 magiging negative 4, 1 magiging negative 1, 0 magiging 0 pa rin. So, mapapansin nyo, equal itong original A sa negative nung A transpose, right? 0, negative 3, 0, negative 3, 4, 3, 0, 1, 3, 0, 1, negative 4, negative 1, 0. So, yung tinatawag na skew symmetric kapag yung A transpose ay equal sa negative nung original matrix or vice versa. Okay? Next, we also have the conjugate of a matrix. So, if all the elements of matrix A is equal to A sub jk are replaced by their conjugates, AJK with line above, then it is called the conjugate of A and is denoted by A conjugate is equal to AJK conjugate. So, yung conjugate, para lang din tong yung concept natin sa complex number tsaka sa radicals. Pag hinanap mo yung conjugate niya, dapat yung second term opposite ng sign ng original second term. So, denoted by yung matrix, lalagyan mo lang ng line above. So, for example, itong given natin matrix na A, 1 plus I, 2I, 3, 1 minus I, 3, 2 minus I, 3 plus 2I, I, 3 plus I. So, itong I natin dito, siya yung imaginary number natin is equal sa negative 1 So, sa complex number na video ko. So, pag hinanap natin yung conjugate ng A, gagawin nyo lang, papalitan nyo lang ng conjugates yung bawat term. Meaning, yung sign ng second term, gagawin yung opposite. So, magiging itong 1 plus I, magiging 1 minus I. Itong 2I, magiging negative 2I. Itong 3 as is, kasi siya yung constant. Diba pag nagko-conjugate tayo, A plus BI, yung imaginary part lang yung ginagawa nating opposite sign. So, A minus BI. So, since 3 is constant, di natin babaguhin. 1 minus I magiging 1 plus I. 3 as is. 2 minus I magiging 2 plus I. 2I. And then 3 plus 2I magiging 3 minus 2I. I magiging negative I. And 3 plus I magiging 3 minus I. So, therefore, ito yung conjugate ng matrix A. Okay? Now, we have the Hermitian and Skew Hermitian matrices. So, Hermitian matrix, a square matrix, is said to be Hermitian when the conjugate of A transpose is equal to A. That is, if A is a square matrix, then A sub jk is equal to A sub kj conjugate for all values of j and k. So, Hermitian matrix naman daw kapag yung original matrix natin A ay equal sa conjugate nung A transpose. So, halimbawa, itong A, hanapin muna natin yung A transpose niya. So, pagbabalik ta rin natin yung positions nung column sa row. So, magiging 1, 1 minus I, 1 plus I, 2, negative 3I, negative I, 3I, 3. And then, hahanapin pa raw natin yung conjugate. So, A transpose conjugate will be, opposite sign lang yung may mga I. So, 1, 1 plus I, negative I, 1 minus I, 2, positive 3I, negative 3I, 3. Okay, so mapapansin nyo, itong original matrix natin na A ay equal siya sa nakuha nating A transpose conjugate. So, pag chinek nyo yung bawat element, similar sila. Right? So, this is an example of Hermitian matrix. Next, we also have the Skew Hermitian matrix. A square matrix is said to be Hermitian when the negative of A transpose conjugate is equal to A, or A transpose conjugate is equal to negative A. That is, if A is a square matrix, then A sub jk is equal to A conjugate, A sub kj conjugate for all values of j and k. So, pag skew Hermitian, lalagyan nyo lang ng negative. So, particularly yung negative down ng A transpose conjugate dapat equal sa A, or the other way around, A transpose conjugate ay equal sa negative A. So, halimbawa, itong A uli natin na given, hanapin natin yung A transpose muna. So, pagbabalik natin yung positions ng column sa row. So, magiging I, negative 1 plus I, negative 3, 1 plus I, negative 2I, negative 4, 3, negative 4, 3I. And then, hanapin natin yung conjugate. So, opposite signs ng may mga I. So, negative I, negative 1 minus I, negative 3 as is, 1 minus I, positive 2I, negative 4 as is, 3, negative 4 as is, negative 3I. And then last step, mumultiply uli natin sa negative 1 yung bawat term kasi kailangan natin ng negative nitong A transpose conjugate. So, magiging multiply lang natin each entry by negative 1. So, magiging positive I, positive 1 plus I, positive 3, negative 1 plus I, negative 2I, 4, negative 3, 4, positive 3I. So, equal ba yung A sa final matrix na nakuha natin? I, 1 plus I, 3, negative 1 plus I, negative 2I, negative 4. Oops, hindi sila pareho. Saan yung mali natin? Trace lang natin. So, ayun. Negative 3, 4, 3I. So, dapat positive pala to. Sorry. Positive 4. Then, positive 4. So, dapat, pag minultiply natin sa negative 4. So, tama na. Okay? Kamali lang ako ng 4. Dapat, positive 4 siya dito. Negative 4 kasi nasulat ko, diba? And then, negative 3, 4, 3i. 4. So, tama. So, therefore, Skew Hermitian matrix itong A. Okay? Next, we have the main diagonal and trace of a matrix. If matrix A is equal to A sub jk is a square matrix, then diagonal that contains the element A sub jk in which j equals k is called the main diagonal of the matrix, and the sum of all the elements in the main diagonal is called the trace of the matrix. So let's say meron tayong matrix A with elements A11, A12, A13, A21, A22, A23, A31, A32, and A33. So dapat yung specific matrix natin ay square matrix para mahanap natin yung diagonal. Pag sinabing square matrix, equal yung number nung row sa number nung column. So in this case, yung example natin, meron tayong 3 by 3 matrix. 3 rows and 3 column. So sabi sa definition, yung main diagonal daw ay yung entry doon sa matrix kung saan doon sa A sub jk, yung j is equal sa k. So therefore, ito yung may mga elements na A11, A22, A33, and so on. So, kasi dito, alam naman natin na yung diagonal para siya yung slant line, di ba? So, automatic, ito yon yung diagonal ng matrix na to. So, laging ganyan, yung naka-slant line doon sa square matrix. Yung mga elements under the diagonal or slant line doon sa square matrix. Okay? So, meron din tayong tinatawag na trace. So, yung trace daw, ng matrix na to, square matrix na to, is add mo lang yung bawat elements ng diagonal. So, it is equal to A11 plus A22 plus A33. Okay? So, halimbawa, meron tayong specific, let's say, 4 by 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, 4 by 4 siya, 4 rows and 4 column. So, automatic, ang diagonal niya ay ito. 1, 6, 11, 16. And then, pag hinanap natin yung trace, add natin to isa-isa. So, 1 plus 6, 7, plus 11, 18, plus 16, 24, 34. So, the trace is 34. Okay? Next, diagonal matrix, a square matrix whose elements below and above the main diagonal are all 0 as shown below. So, pag sinabing diagonal matrix, dapat yung elements niya doon sa square matrix na yon, yung diagonal niya lang yung merong value except 0. Okay, so lahat na nung elements above and below the diagonal ay 0. Okay? Next, scalar matrix. A diagonal matrix whose elements main diagonal are the same as shown below. Okay, so isa siyang uri ng diagonal matrix, meaning yung mga elements other than the diagonal ay 0, 0 na dapat. Tapos, pare-pareho yung element dapat doon sa diagonal niya. For example, dito, 2, 2, 2. Parehong 2, 2, 2. Okay? So, yun yung scalar matrix. Next, identity matrix. A diagonal matrix whose elements in the main diagonal are all 1 as shown below. So, this time, special case siya ng scalar matrix kasi dapat yung diagonal niya laging 1 lang. So, diagonal matrix din siya kasi yung elements other than the diagonal ay puro 0. But this time, para maging identity siya, dapat 1 yung mga elements ng diagonal. Okay? Next, we have the triangular matrix. A square matrix whose element is below or above the main diagonal are all 0 as shown below. Okay, so triangular matrix meaning dapat square matrix din siya kung saan either dapat yung mga elements below or above the main diagonal are 0. For example, dito sa A, di ba ito yung diagonal natin? So, upper triangular matrix siya kasi lahat ng elements below the diagonal are 0. Or may mga values lang doon sa matrix natin ay yung number above doon sa diagonal, which is 4, 3, 4. Kaya upper triangular matrix. On the other way around, meron tayong lower triangular matrix. Meaning, above doon sa diagonal natin, 0, 0 yung mga element at below the diagonal lang, meron tayong non-zero values. So, for example, 6, 4, 3. Okay? Okay, so I think that's it muna for the introduction and different definitions of matrix. So, next video, ituturo ko naman sa inyo yung iba't ibang operations at applications na ng matrix. Okay? So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.